Welcome to Study Loop.
So here we're trying to find the force of the radiation pressure. So we can say for part A, F sub r would be equal to P sub r multiplied by pi r sub E squared. We know that this is going to be equal to the intensity over the speed of light, c, and then this would be again equal to pi r sub E squared, so the radius of the Earth squared, and we can solve. So F sub r would then be equal to pi times 1.4 times 10 to the third watts per square meter, multiplied by 6.37 times 10 to the sixth meters. This would be squared, all divided by the speed of light, 2.998 times 10 to the eighth meters per second. And we find that here the force of the radiation pressure would be 6.0 times 10 to the eighth newtons. For part B, we want to find the gravitational pull of the sun on the Earth. So here, force of gravity would be equal to the gravitational constant times the mass of the sun multiplied by the mass of the Earth divided by essentially the distance between the center of the Earth and the center of the sun, quantity squared. We can solve 6.67 times 10 to the negative 11th. That's the gravitational constant. This would be Newton meters squared per kilogram squared, and then multiply by 2 times 10 to the 30th, the mass of the sun, times 5.98 times 10 to the 24th. And then this would have a units of kilograms. This would have a units of kilograms. So the units here would be kilograms squared. And then this would be all divided by the distance between the center of the Earth and the center of the sun. So 1.5 times 10 to the 11th meters, quantity squared. And we find that the force of gravity, we could say the force of gravity of the sun on the Earth or on the Earth on the sun, they're going to be both equal to each other due to Newton's third law of motion. So the force of gravity would be equal to 3.6 times 10 to the 22nd newtons. And as you can see, this is going to be much, much greater than the force of the radiation pressure. That is the end of the solution. Thank you for watching.